Hello everyone, welcome back to the channel. Today's video is about Visual Effects Graph or VFX Graph. For this, I'm using Unity version 2023.1 and I have a project set up in URP. Now a quick heads up, this video will be basic introduction or let's say getting started type video about VFX Graph and particles in general. So if you guys know or have worked with VFX Graph already, you can safely skip this video and wait for my tutorial video, which would be out within 2 days, give or take a day or two, or you can stick around and hopefully you might learn something new. Now with that out of the way, let's get down to the business. Let's start with what are particles. Now this is the homemade definition, so bear with me. Particles are many small images or meshes to represent visual effects that are typically difficult to portray with only single mesh or sprite. Example of visual effects where we can use particles are environmental effects like snowfall, rain, mist, fog, fire, or gameplay effects like puff of confetti when user crosses the finish line. And to work with particles, Unity has two methods: Particle System and Visual Effects Graph. Particle System is older and is Unity's default system. VFX Graph is newer, node-based system. So how do we know what system to use? General conception can be that VFX Graph is newer, so we should use VFX Graph. Not quite in this case. It is not like VFX Graph has superseded the particle system. They have some distinct differences and we should choose one that fits our requirement the best. Let's talk about those differences. First is the render pipeline support. Particle system is supported on every render pipeline. VFX Graph is only supported on HDRP and URP and can work with your custom scriptable render pipeline as well. Also keep in mind that it is only production ready on HDRP. In URP, it is still in preview phase. Second difference is Particle System is CPU bound while VFX Graph is GPU bound, meaning Particle System will run on your processor and VFX Graph will run on your graphics card. That will bring us to our third difference, that Particle System can support only hundred thousands of particles while VFX Graph can support millions of particles. Now of course these are arbitrary numbers and actually depends on your hardware. For example, if you have AMD Threadripper, you could get away with millions of particles even with particle system. The fourth difference is particles can interact with physics of rest of the world or scene in particle system while VFX Graph cannot. Again, this is because physics calculations are done on CPU and particle system also run on CPU, so particles can interact with underlying physics. Meanwhile, VFX Graph is pretty much GPU bound and our graphics card does not know what our processor is cooking. Now that does not mean we can't use our own magic tricks to make it work, but there is no built-in solution to do so. Fifth is, now take this one with a grain of salt because this is my own opinion, particle system can be used for simple effect while VFX Graph can be used for more complex effects. Because personally, I could not replicate some of the effects with particle system but can do so with VFX Graph. Keep in mind though that I am not the VFX god, so my opinion is pretty much biased and based on my own skill set. I'm sure there will be someone out there who can make jaw-dropping effects with particle system while I could not match them even with VFX Graph. So it's not what tool you use, it's about how you use it. Also, I said that VFX Graph is for complex effects. That does not mean you could not use it for simple effects. So that's the different points to help you identify what should you use. My recommendation will be, if you are not working with built-in render pipeline and does not require physics collision, go for VFX Graph because it is good to offload as much work as we can on GPU for visual fidelity. Okay, now how do we use VFX Graph? For that, you must have a project with HDRP or URP. Then go to Window, Package Manager. In Package Manager, make sure you have selected Unity Registry from the drop-down. Then scroll all the way down, find Visual Effects Graph and hit the install button. Now you can create VFX Graph, so right click, create visual effects, visual effect graph. We will create rain effect for the demo, so let's name it rain VFX. To use this asset in the scene, let's add visual effect game objects. So in hierarchy, right click, visual effects, visual effect, we will call it rain. It has a visual effect component. We will drag our VFX graph in the asset template slot, and we can see the default particles. To edit our effect, double click on our asset, and we will be presented with VFX graph window. Here we have our blackboard, our default particle system, our particle controls, and other cool stuff. We can also name our system to stay organized. And these 4 nodes you are seeing are called context nodes or context, and the blocks inside of them are called attribute blocks or blocks. We can also add various nodes outside of our system, like add node. This node is called operator block or operator. Now these 4 context nodes are the foundation of any visual effect. Spawn context determine how many particles to spawn and how to spawn them, like spawn them continuously or in bursts. Initialize context, think of it as the start method of our mono behavior, where we initialize our particles, like setting the lifetime, set the initial velocity, etc. This update context is similar to our update of a mono behavior, where we update our particles during their lifetime, like adding some turbulence or adding other forces. And this last output context will determine how to display or render our particles, like we can set the texture, render them as sprite or meshes, set their orientation, and so on. To create the rain effect, first I'm going to delete everything so you can very easily understand without getting overwhelmed. Now we want to spawn the particles, so let's create a spawn context. And we want to spawn them continuously, so let's add constant spawn rate block. Now we can define how many particles we want to spawn each second. We would like to do that from the inspector, so let's create a float property, call it rain intensity, give default value of 300, drag it in and feed it into the rate. Now we want to initialize our particles. For that, let's create an initialize particle context. Here, this capacity determines the maximum particles to render. Set it to 5000. Bounds mode determines how do we like to set up our bound. Recorded will automatically take bounds from the attached target object. Manual and automatics are pretty self-explanatory. These bounds are culling area for our particles. Any particles outside of this area will not be rendered to our camera. Also, if our bounding box is not visible to our camera, particles won't be rendered. Now, if we cannot see the bounds in scene view, then it means we haven't provided the target object. For that, go to this anchor chain thingy, select the target object, and now we can see the bounding box. Now I'm going to set its size so that it covers my entire environment. And we don't want any padding. Now to actually render the particles, we need an output context, and we want to output them as quads. So let's create output particle quad context. We also need update context, otherwise particles will not update. Then we will take initialize particle nodes output, feed it into the update context, and take update context output and feed it into the output context. I will give proper name to our system. In output context, for the main texture, I'm going to use this default sparkle texture and set the blend mode to additive. Now let's add initial velocity to our particles. For that, in the initialize particle context, let's add set velocity random block. Here this per component means different random velocities for each particles, while uniform means same random velocity for all particles. I will add some random velocity. We need to set the lifetime of our particles. For that, let's add set lifetime block. Lifetime is the duration of our particle to stay alive in seconds. After that, it will be destroyed. I will set it to 3 seconds so that our particles can fall below our plane before getting destroyed. Now our particles are spawning from single point. Let's spread them out a bit. For that, we will use set position block with shape a box. We will set the position mode to volume, so our particles will spawn from any point within this box. I will set the size to cover the entire environment. Now notice that our texture looks like droplet going upward, so we will rotate them using set angle block. Let's rotate them 180 degrees on Z-axis. And our droplets look too thick like snowflakes, so let's set their scale using, you guessed it, set scale block. Let's freeze them from X and Z axis. Now we will not add anything and update context. So why keep it, I hear you ask? Well, if we delete it and directly feed initialize context output to our output context, our particles will not update over its lifetime, so we need update context. Let's add color to our particles. For that, we will use output context. Let's add set color block. We will control it from the inspector, so let's create a color property. Call it droplet color. Give default bluish color. Drag it in and feed it into the color. Lastly, if I increase the scale of our particles and view it from the sides, you will realize that they are just 2D quads, so we will make them always face towards the camera. For that, let's add orient block with mode face camera position. Let me just readjust the scale. Save our graph and we have simple rain effect. And just like shader graphs, we can override the properties in the inspector for a customized look. That's pretty much the video. If you find the video helpful, consider like, share and subscribe. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.